Okay, hello everyone. I'm Sojang Kim, and today I'm going to explain I'm going to give you the instruction for the exam two. In other words, the final exam. Okay, yes, final exam is coming. So here's the information. Final exam will be held on June 9th. Okay, and then which is week 15. Is a part of the week 15, I guess. And then the time is exactly same as our class hour. So it will start at 10:30 until 11:40. Got it? So you will have 70 minutes, which is just same as you have in midterm exam. And other things are quite similar really to the midterm exam. So scope, of course, so scope of the exam will be lectures from the week 9 and week 14. So in other words, any logic or agent-based simulation is not a part of the exam because they will be addressing week 14 and 15. So please focus only on the arena part, okay? The simulation modeling with arena software. All right, and then here's other things you need to know. So you can bring one cheat sheet and both sides of the A4 paper, as you know. So you used a cheat sheet last time, right? So bring the same one, okay? And then record your screen and activities during the exam via your cell phone. And you can use a computer, of course, and then your computer, you can use Excel, Arena, or English dictionary if you necessary. Got it? And you will have 90 problems, and then 14 of them will be very simple, okay, problems. And then also particularly it is associated with what simulation modeling part, because the most of contents after the midterm and each uh, most of contents addressed in addressing the class after the midterm is which is likely really related to the simulation modeling. So that's why. And then you can have other applications and then model interpretation question. So which is 5 problems, and each problem will have a 6 point. Got it? So total will be the 100 points. And what else? Okay, so submission. I think you already did in during the midterm exam. So everything will be exactly same as a midterm. Okay, so therefore after the exam, you need to submit the following items: files, first of all, files, right? Files, and then you need to submit the files to the e-class folder, right? Right after the exam, which files? So technically, cheat sheet, one solution note, and Excel and Arena files. Also, and plus, and after that, if you have time or during the evening, you can submit your video, right? And then also, if you have a video, and then basically you can submit to me via email. So here's my email address, right? So if you cannot, so let's say you have another exam right after this, so you can have enough time to compile your encoding your in the video, then you may need to submit your file next date of the exam, right, which is June 10th, right? In that case, please email me about your situation so that I can expect your late submission. Got it? So if you have any question, and then if you have a sudden accident, and then definitely please let me know. Okay? Okay, let me briefly review the lectures, okay, addressing chapter 5, 6, and 7. All right, so in the model, especially advanced model, we have actually discussed the simple core center system. And here's the overview of the simple core center system. Hopefully you still remember this model. And it has 3 different services. So it considers 3 different services such as technical support, sales information, and order status, right? And once there is incoming calls, and then it checks the availability of trunk line, right? And then if there is avail of trunk line, and then the call will seize one unit of the trunk lines, right? We have about 26 trunk line, right, in the model. Yes, here is information. And then the entity go through the decide module to determine the call type, right? since we have three different call type, and in other words, services, and it has go through the one of these services with these probability values, and then after the service, and the entity incoming calls can release the resource, which is trunk line, and then leave the system, right? Leaves the system. Yes, right. So in order to model this simulation model, and basically we use new modeling techniques, right? Called in the advanced process panel. You remember that? Hopefully you remember this, right? So here is overview of the arena model, and then so this is a part of the core libraries, right? And then this is a tech support core and sales core, and then here is a order shader core, right? And after that, it use a release module to release the 1 unit of trunk line, and then assignment is here, and record module, and then dispose module. Yeah. So if you don't know the meaning of these modules, and then you will have a trouble in your exam. So please review the video, okay, lecture video, if you don't have anything here. And then we have another thing called cutoff logic, right? So cutoff logic is a key actually concept in this model, as you know. Why? Because we have this condition, right? Which condition? So here is a condition, right? So technically, service system, actually service call center can operate from 8 a.m. to 6 p.m., right? If you know correctly, if I know correctly. And then, however, small portion of the staff stays until 7 p.m. to process the incoming calls, right? After the 6 p.m., right? So incoming call will be shut down after 6 p.m. So there is no more incoming call, right, in the model. So that's why we have to have a cutoff logic. However, we want to process all the calls enter the system before the 6 p.m., right? So that's why we run the simulation a little bit more, particularly more than 6 p.m., right? And that's why you have to have the cutoff logic to make this happen. Right, where is the cutoff logic? Let me go to the cutoff logic here. Yes, so here's a major concept of the cutoff logic, right? And we have a course entity, right, which is entity, and then it operate, and service system will operate from 8 a.m. until 6 p.m., which is 600 minutes. So that's why if you go to run setup of this model, and then you will have 600, right, as the length of the simulation run. And then arrival time of the first call is 0 minute, right, which means 8 a.m., right? And then interarrival time following this exponential distribution with this parameter, right? So that's why you can actually type all the parameters here. Good. However, I mean, in order to make a cutoff logic, you need to have more, right? Which one? Which is, so you need to use a variable called the calls per live, and then another one is a max calls, right? So initial values of the max calls and is a 99 just a big number, right? So that there will be many incoming calls can enter the system, right? There will be many incoming calls, right, in the system, entering the system. So after that, anyway, so you have to have another create module, which will generate the logical entity, and here's the name of the logical entity, which is a library cutoff, right? Cutoff, right? This is name of the entity here. Yeah, it's a very small, but if I zoom in a little bit, yes, you can see this, right? A library cutoff, and definitely we don't have to have any next item of this, right? So that's why you can just type the bin number constant, right? Should be constant. If you use a random number, and then maybe there is a small possibility to have another next entity, so so you will get trouble with a very small probability value, so small chance. That's why just put the large constant value as an interval time, so that you will have only one logical entity generated by this create module. And entity per liable is 1, and max liable is 1. So anyway, there will be just one entity in this there will be one entity generated by this create module, and first creation is 600, so which means at 6 p.m. we will generate this entity, right, logical entity, so that we can shut down, right, shut down the cut off the any new incoming calls, right, after 6 p.m. Good, at 6 p.m. And then this assign module, by using this assign module, you can change the value of variables. So we have two variables, max course per arrivals, and as you know, these variables are used in where? Using the previous original create module, in here and there, right? So since this one initially has a big number, we need to change its value, right, to the 1. Don't put 0 here because it will cause the error. So that's why in Arena you need to put 1, bigger than 0 anyway. So as a value of the max arrivals. So this value should be greater than equal to 1. So that's why we put 1 here. And then cost per arrival becomes 0. So you can put the 0 here so that you can assign 0 value to the cost per arrival. So initially this value was what? This value was 1, right? Because we want to consider the 1 core per arrival, right? So that's why. You remember this? Yeah, hopefully you remember this. If you cannot remember this, and please watch my previous video and then try to understand the logic of this simulation model. Because I'm not going to ask you to use Arena software to develop the simulation model during the exam. However, you need to understand what's going on, okay, in the simulation model, because I'm going to ask you to interpret the given model in the exam. So that's why. Right. So anyway, so by using this cutoff logic, and you can actually you can shut down you can cut off the incoming calls after 6 p.m. as I mentioned before, right? So here I'll explain everything, I guess. So here's an example of in the simulation model. So at 8 a.m. actually your max call and course arrival have these values. So big number, and then just course per arrival is 1. So this is 1. This is 99990. I missed the 19 here. So anyway, big number 999999. Yeah, should be. And you have a 69 here. Yeah, and then at 6 p.m. so this create module will generate the cutoff logic, right? Cutoff entity. So we will change the value of the what? Max course and course per arrival, right? By using this assign module. So max call will be 1 and course per arrival will be 0, right? And then simulation will be terminated in between 6 and 7 p.m. right? If there is normal calls in the system. Got it? That's how you would develop the model actually for this call center. And we actually also addressed many new modeling issues, particularly in the advanced process panel. You have used a cease delay release module separately, right? Instead of the process module having this cease delay release option, right? So difference is that if you use this highly detailed model, and then you can do whatever you want in the between cease and delay, or delay and release. Okay, so that's why it is known as advanced process panel modules in the advanced process panel. So let's look at the cease delay release modules. So cease module, what it sees 1 unit or more unit of resources, right? So resource entity can seize 1 or many resources, right, by using the seed module. Okay, and delay is what? So by using delay module, you can spend some time in the system, right? So that's what you call delay. So delay 10 minutes. So you can put 10 minutes over here, right? And release module, if you don't use a release module, and then your entity will just cannot release the resources, so that other entities cannot seize them. existing resources. So that's why you have to put the release module before entity leave the system. So okay, so that's why you have to have a seize, delay, release. Or you can skip delay if you want it. You can skip release if you want it, but I recommend you to have seize, delay, release together. Okay, so here is the example. Okay, if you, let's say you only put the seize module over here and then with the create and dispose module, and then definitely create module we generate entities, right? And here is the information. 5 entities are created by the only ones at time 0. So this create module generates 5 entities at time 0. So we have 5 entities generated by this create module, right? And then resource capacity is 1. Got it? So first entity and second entity, third, fourth, fifth entity are generated at the same time at time 0, right? At time 0. And first entity will seize the 1 unit of the resource, right? Got it? However, we only have 1 resource, so other entities cannot seize that resource. Why? Because first entity already left the system without releasing the resource. Got it? So first entity left the system, but it did not release the resource. So other entity have to wait in the queue, right? Have to be in the queue until the first and this resource is available, which will not happen again. So at the end of simulation, you will have this value. T now 0, right? There is no delay, right? There is no delay. So that's why simulation time at the end of simulation will be 0, and then number of entity in the queue, NQ, number of entity in the queue will be 4, right? 4 entities are waiting for resource available, right? And then resource status is busy because it's not released by the first entity. Got it? So that's why I recommend you to put the release module if you have a seize module. Okay. Another example. So let's say you have a delay module here instead of having other seize or delay and seize and release modules. And then you at the same time you create the entities, 5 entities at time 0. So this by this creating module, and resource capacity is still 1. Delay time is 10. Okay. So you generate 5 entities here, and then 5 entities go through the delay and then dispose, go through the dispose module. What will happen at the end of simulation? So simulation will run for only 10 minutes. Why? Because there is no seize module. So all the entity can go through the delay module without worrying about seizing the resource, right? Because there is no seize module, right? So 5 entity will enter this delay module at the same time, and they spend how much? 10 minutes at the same time, and then leave this system at the same time. So number of queue, actually there is no queue anymore, right? Because there is no siege module. So number of queue is just empty. So you don't have any entity in the queue. And resource status never used, right? In this model. So that's why the status of the resource 1 will be idle. However, T now at the end of simulation will be 10 because there is a delay module. Okay. Got it. So this is pretty much about the major modules using the using the advanced panel. Actually, we have so many concepts in this simulation model. That's why I like the call center model. Another one is that we need to consider the priority for seizing the resources, right? Using the different process modules, right? So I guess you already remember this, right? So sales step. So there was a seize module, right? To seize 1 unit of the sales step, right? And we gave the different priority to seize the resource, right? You remember this, right? And then we use a shared queue, right? So we make the queue the can be shared by the multiple modules, which is the sales call and then also talk to a sales staff. This is a seize module, I guess, right? Okay, so that's I already explained how to prioritize the different process modules, right? To seize the same resource, using the same queue, which is shared queue, right? And also the course arrival. There's another concept about the course arrival. Particularly, I already explained the non-stationary Poisson process. In other words, thinning method. You remember this? So thinning method. You have to remember this. Okay, so since our schedule, if you look at the arrival schedule of the entities, and then definitely there are different rate over the time. So six people incoming calls maybe. Let's say there are six incoming calls customers. Yeah, six customers during the first 30 minutes, and then other three another during the another 30 minutes, and three for the from 11 to 11:30, and then 60 customers from 11:30 to 12. Okay, so you have different rate over the time, and in this case you need to consider the non-stationary Poisson process. So you remember the Poisson process, right? Which is widely used to address the arrival rate or arrival behavior of the customer for the system, right? So non-stationary means lambda value is different. Lambda, which is arrival rate, changes over the time. So that's why lambda is a function of the time t in this case. Okay, every rate varies over time, which is lambda t. Okay, so in this case, lambda t equals to 6, lambda t equals 3, lambda t equals 3, lambda t equals 60, something like that. Correct? Yes, you got it, right? And however, there is a potential problem if you have a non-stationary Poisson process in the simulation. Let's assume that an entity arrives at t now of 11:29. So 11:29. So here we have 11:29. We have one entity entering this system. Okay, here the third time slot. Right, and then interval time at that point is exponential following the exponential 20 minutes, right? The 20 minute exponent, right? Interval time. So which means another entity can be generated after 20 or bigger than 30, because this is exponential distribution, right? Exponential distribution shape like this. So it may take more than 33 minutes. It's possible because this is a random distribution, right? So let's say next arrival has been scheduled after 33 minutes, right? Because we are using this random distribution, exponential distribution. So although mean value is 20 minutes, however, since the property of the exponential distribution, you can have 100 minutes or the 50 minutes with the really small chance, right? So let's say we have 12, 2, as another entity at 12, 2. In that case, how many entities we have from 11:30 and 12 during this interval? 0, right? So technically, we cannot model this characteristic, okay, in this situation. Got it? So it basically causes a serious problem when you run the simulation, especially when we want to evaluate the performance of the system. However, since this mistake, we cannot really consider the customer's behavior or property or system performance during this time, right? Even though actually there are really many customers during this period, right? So that's why people think about another method to overcome this issue, right? Which is thinning method, solution to handle this problem. Okay, so in order to use this one, you have to do what? You have to use the maximum arrival rate. In our previous example, maximum arrival rate was what? 60, right? During the 30 minutes. So interval time is what? Was 1 minute, right? Per hour, I mean. Yes. So 1 minute, 60 arrivals per hour. So the interval time is 1 minute, right? So in that case, since the maximum the arrival rate is 1 minute, the 60 per hour. So interval time should be 1 minute, right? And then disregard the appropriate portion in each period. In other words, let me explain this with this example. So we have this desired interlevel time, right, for each time period, 10, 20, 20, 1 minute. So these value were given by what? Given by this level rate information per hour, right? Yes, so you need to transform the original arrival rate into the inter-arrival time, right? You can take an inverse of the arrival time, right? So 10, 20, 20, 1. So 60 over 60 will give you 1. Got it? So, and then mean arrival rate, so max arrival rate. If you find the max arrival rate, and this should have the max arrival rate, right? And which means this has, so you need to find the mean inter-arrival time, because the inverse of the arrival rate will give you the inter-arrival time. That's why. So mean value will be 1 minute, 1 minute, 1 minute, 1 minute, right? So you generate in the simulation, you have to generate how many. So every 1 minute you have to generate the entities, and then disregard 90% of them to meet this desired interlevel time. Okay, right? In other words, generate 10 entities during the first period, and then delete the 9 of them, so that you can have only one entity, right, generate in this period. Similarly, you can remove 95% of the entities during these periods, so that you can meet this desired interlevel time. Same thing for the next interval, and then last one, you don't have to disregard anything, right? Because the interval time is 1 minute, and then this desired interval time also is 1 minute. So you have to generate the entity at every minute, right? And then use them all. Got it? So this is a dating method. And if you cannot remember this, yes, please review the material. Also, there is a explanation about the statistics, right? And then also the cost of the system operation, right? However, since I don't have really enough time for explain everything here, so please review the material, right? And last time we considered the 4% of tech call need for the assistant, and then calculate the service time, additional service time, using the member selection in a set, right? So you remember this, right? We have several options for the set, and random, cycle, preferred order, specific member, and the largest remaining capacity, or the smallest number busy, right? So we have these rules to select the specific step, right? For this 4% of the tech support calls, right? Remember this, right? Please try to remember that this property of the set. And also variable array, I explained this one, right? So you need to think about the variable array. And then also I consider the time persistence statistics, right? And then we use this kind of equation, WIP, work in process, right? So you need to remember this one. If you don't know everything, and then I know that you cannot remember everything here. So that's why you can bring your cheat sheet. You can write down everything you want in your cheat sheet, right? So yes, please do so. Anyway, guys, after you got the output of the simulation, and then you can analyze it. And as you know, actually we already did, right? So during there are so many services requests, and during between noon and 4 p.m. So we have a change of schedule of the salesperson, right? Last time, and then also calculate the resource cost or operation cost, right? And using this equation, got it? And then collect also additional statistics, right? So that we can determine how many additional steps we need, right, to handle all the services, right, without causing any dissatisfaction of our service. Also, we make multiple applications to get the statistically reliable output, right, by using one set of options. And also I already mentioned about this part. So you need to, in order to investigate the number of salesperson, right, in the resource, and basically you can use a variable, right, variable in the schedule, called the new cells in here. And also we use the expression to calculate the resource cost, right? So also I introduce MR function for you, right? Which is, right, unit of the resources, right? Represent the unit of resources. All right, and also we worry about the entity, the waiting time of the each customers, right? So you actually use this entity waiting time option as well. Yes, we did a lot in this call center model. So that's why you need to really fully understand the functions used in this call center model. Okay? Okay. So let's talk about another things. So the statistical analysis of the output from the terminating simulation. So chapter 6, which is a kind of easy, right? Because you need to use existing tools like a output analyzer, right? And I'm not going to explain this one too much, right? Output analyzer, so you know how to use it, right? You need to know how to conduct paired t-test, right? Using output analyzer, without output analyzer, and then process analyzer. If you need to consider the multiple scenario at the same time, not two, then you need more than two. Then you need to use a process analyzer, right? Okay. And also last one. So you need to if you want to do the simulation based optimization, such as if you want to maximize your objective function or minimize object function. In our case, we wanted to minimize total cost, right? So total cost while the person's rejected call is less than or equal to 5%. So that's why we add a constraint. Also, we have object function, right, in OptiCast. And I believe that you know how to use OptiCast, right, with Arena. Got it? So let me quickly review the theoretical part in this chapter. Okay, so we have a terminating simulation model and a steady state simulation model, right? If you right? So terminating. So for call center model is a kind of terminating, and not kind of. So call center model is a terminating simulation because we specify the starting time and stopping time, right? If you want to know the simulation forever, and then you can consider the steady state simulation. Okay, and also I will address the definition of the warm-up period, right? Particularly for the steady state simulation, you need to really remove the warm-up period. And then please review this material if you have any time. And also particularly in the steady state simulation, you need to have this condition, okay? Because you need to run the simulation forever. So you don't have to have the incoming calls more than the service greater than the service rate. So incoming rate should be less than or equal to the service rate, less than the service rate particularly. Okay, this is a low, right? So low should be less than 1. Otherwise, your customer is too many, so you cannot handle it. So that's why sometimes when you run the simulation model, and then you will have a error message, right? So simulation model cannot handle the entity because so many entities are generated in your simulation model, something like that. Because your simulation model, service rate of your simulation model is not greater than the arrival rate of the entities. That's why. Okay, so your system should be stable. In other words, your system can enable to handle all the customers enter the system under the given time. Okay, so sometimes your system should be idle. Got it? All right, so anyway, once you have an output of your simulation model, you need to really you need to analyze them, right? So output analysis. So you can have a point estimate, which is one value, right? Single number of the statistic, like a sample mean or sample variance, which is just single value or single value. Otherwise, you can consider the interval estimate. You can consider to use interval estimate, such as confidence interval, right? So confidence interval is better because it gives the interval more information, in other words, right? Range, right? With the shape of like this. So that's why. Okay, and also in order to calculate confidence interval, definitely you need to have a half width, right? Half width. So you can subtract this half width from the sample mean and then add this half width to the sample mean by to have this confidence interval on this mu, right? You remember this, right? So you run this when? Second grade? Okay, sophomore. All right. So also, if you have a smaller confidence interval, that means you have your output is very precision. In other words, it's better, right? Or accurate. So in order to have a smaller half width, you need to increase number of samples, right? In other words, increase number of n here, right? So in other words, increase number of applications. So however, we don't know how many application we need. So that's why there are two approaches to calculate the number of intervals, number of applications to have a certain interval or half width, right? So here's a half width from the initial value. So scale of this h0 and then target half width is given. So h scale of the h, and then by using this equation, and n0 is usually 5, but in order to get this half width, you need to run your simulation model with the n0 number of applications, right? So by using this equation, you can calculate n value, which is required or desired number of applications, right? So this is approximation approach to determine the number of applications. So in other words, the value is not really give you the exact half width you want to have. So first formula give you this kind of 80, and then second formula give you 106, right? And then if you change the number of application to 110, and then run the simulation, and then your half width is slightly greater than the 250, right? So it's an approximation approach. So it's not going to give you the exact value you want to have. So anyway, but still good approach, right? To calculate the number of applications from your initial simulation runs. And also, in order to compare the two scenarios, you need to consider the pair t-test, right? Pair t-test. And then last time we used a call center model, right, to compare the two scenarios. And let's look at the concept of pair t-test. Actually, you don't need to really use output analyzer if you know the concept of pair t-test. So hopefully you remember this one. So let's say you run the simulation to the same simulation with two different scenarios, okay? And mean value vary over two different scenarios. So H0, the mean difference between paired observations is 0, so same, okay? H1 will be what? Different, right? So this is H0. We want to test this one. And you need to calculate the DI, which is the output difference for pair I. So with the difference between two observations can on each pair. And this is a 95% confidence interval for two means difference. So this is a what? Average, right? Average of DI. And then this is half width, right? So here's the example of the pair t-test. Let's say you have one simulation model with the scenario 1 and then scenario 2, right? So, and then I means number of applications. So first application, second application, third, fourth, fifth, same thing. First, second, third, fourth, fifth, right? So in order to, if you have these two, so it's a one pair 1, this is a pair 2, pair 3, pair 4, and pair 5. So you need to calculate difference for each pair, which is DI. So pair 1 give you -4, right? And then pair 2 give you 1, and pair 3 will give you -3, and pair 4 will give you -1, and pair 5 will give you 1, right? Very easy, right? So 1, 2, 3. So we have 5 values, and then you can get the average of these 5 values, right? So minus 6 over 5 will give you minus 1.2. And then standard deviation of these 5 will give you like this. And then if you find the t-value from the t table, and definitely you can get this number. Don't worry too much about it. In the exam, I will give you this t. So don't worry too much about it, okay? Okay, and then 952 mean the difference will be at the end like this. So what's the answer? So because this interval includes 0, so we have to accept H0. In other words, there is no really great difference, right? So scenario 1 and scenario 2 are same, in other words, right? No, there is no difference in scenario 1 and scenario 2 according to this confidence interval. Yes, the last chapter, chapter 7, entity transfer. So instead of using the just connection between the module, you can use a route and station module, right? To animate, basically you can use animation in this case. So especially when you develop the model for the distribution center and or logistics, and you may want to use this route and station module. So actually I really have more modules, but due to the time limit, I cannot really teach you everything you want to use. Okay, so resource constraint. Last time I mentioned about the resource constraint transfer and then material handling devices, right? So resource constraint transfer is what? So entity can transfer something, but it has a limit of the capacity, like using a car with the 4 seat. Okay, something like that. You can actually use a resource constraint transfer. However, you can actually animate behavior of the car or forklift or truck and wheelchair and so on. Definitely you need to consider the transporters and then conveyors, okay, which they are part of this material handling devices. Anyway, so but you don't need to worry too much about everything, because I only explained the small manufacturing system, right? So here we have small manufacturing system with 4 cells, and then part of library is here, and part departure station is here. We have station for each cell. So this is a typical type of the shop floor, right? So manufacturing cell. So in this case, in order to consider this different part type production, we have what? We have sequence module, right? We use the sequence module. Remember that? Also, we use the station and route module as well. So we gave the 2-minute delay for the travel from the station A, station 2, B, right? Something like that. Yeah, from the station A to the station B, something like that, right? And also we use a expression array, right, in this module. And another thing is that since the cell 3 has 2 different machine, old one and new one, and so we use the variables, right? Remember this. And then in the expression, in the process module, we actually use this expression, right? Yeah, hopefully you remember this. And sequence data module is the most important actual concept in this entity transfer. So if you use the sequence data and the sequence data module, and then with the sequence set and sequence, and then basically you can consider the different operations for each part type. So we have 3 parts, right? Part types in this module, right? So for the part 1, part 2, part 3, you generate these different steps, production steps, schedule, basically, right? This is a sequence. This is what is known as a sequence, right? And also you can assign some values over here, right? So in the advanced set, you can create the one set for the sequences, because we have 3 sequences, right? So these names should be right exactly same as these 3 names, right, in the sequence. That's what we call sequence set. So because there is no specific type here, so you need to choose other, right, when you generate a sequence set in advanced set module. All right. So anyway, so once you have the set, sequence set, and basically you can actually render your model, right? And so that the entity can just stop by the four different cells based on their sequences, right? Uh, yes, I think we have six stations. I guess one, two, three, four, five, six. Yeah, six stations, right, in the simulation model. And here's the overview of the uh, this entity transfer module, right? So this is pretty much about the explanation of the entity transfer. Yeah, I know this is very short because I'm just reviewing this material. You already actually made this model right before, so that's why. Okay, so please review all the materials before you take the exam. So like chapter 5, 6, 7, and then take the exam. Also you can bring your one page cheat sheet, so please write down everything you want, and then so that you can get the good score in the exam. Okay, thank you.